Don't write this down. I want to know if there's any of you that can do that in your head. 30 times 18. And if you can do it in your head, be also prepared, because I'm going to ask you what method you use to do it in your head, because there's more than one way that you could figure this out using mental math. All right, who has an answer? Amanda, what do you have in your head? $30 times 18. Giuseppe, do you have an answer? What do you got? 570? Close. T-Mose. All right, the answer happens to be 540. Tyler, I want to know how you did it.
I took my 0 at first, I just did 8 times 18.
All right, that's one way of doing it. If you can do 18 times 3 in your head, that's going to make 54, and then you use the 0 trick to tack on a 0. There's another way to do it. And the reason why I want to kind of generate some ideas is because I'm hoping somebody will hit on the idea that really is the focus of what Lesson 10 is about. And I'm not saying that the way that you've done it in your head is right or wrong. I just want to see if we can make a match for the way that Lesson 10 teaches you mental math, because it's going to also come into play when we do multiplication of decimals. Joe. Okay, so you took the 18 and you broke that up. How many of you did it that way? He took the 18 and said, okay, that's a 10 and an 8, right? Yes? 30 times 10 is, because zeros are our friend. We like zeros. So if we could do 30 times 10 in our head, that makes it easy. And then 30 times 8 is not too bad, because 3 times 8 in your head is 24. Add a 0. So if you do 30 times 10, you get your 300 here. 3 times 8 plus 0, you get 240. And then you add 300 plus 240 in your head, you get 540. Okay? That method by which Joe just described, and some of you also had, is called using the distributive property to figure out the answer. And that is the focus of Lesson 10. Okay? Let's do this, because we're short on time. This warm-up took the place of what the actual warm-up is on the original page. Go to page 2. What I've found in years past is kids like Lesson 10 because once you know what to do, it pretty much flows nicely, and then when you get that question on the test, everybody winds up getting a full credit on it. But I got to show you what to do. Okay, so I have 27 times 400. Actually, go to this page. Sorry. 30 times 12? Okay, good. You take the number that does not end in a 0. That's the number you're going to break up. So out of 30 and 12, which number are we going to break up? Well, write 12 here. That's the number you always want to break apart. Because we want to keep anything that ends in a 0, keep that intact. 0 is our friend. We like things with zeros. Page 2. All right, next. The number that you did not break apart, which is 30, goes outside the parentheses on the next line. Take the 12 and break it up to two numbers that add together that make 12, and one of them has to end in a 0, because 0 is our friend. So what plus what?
10 plus 2.
10 plus 2 makes the most sense. Some people say, well, why not do 7 and 5? Well, you can, but it's always easier when we can make numbers inside the parentheses that end in a 0 as well. Because as these numbers get larger, and you'll see when we start doing decimals with this, 0 is our friend. We like zeros. Obviously, after you make 1 a 10, you have no other choice to make the leftover a 2. So you can't have them both end in a 0. It doesn't work. Now you take the number outside the parentheses, which is 30, and you multiply it by each number within the parentheses. And I like to show it using arrows so you can visually see it. It's 30 times 10, which I'm going to write here, just to show you what I'm doing, plus 30 times 2. Now we're going to evaluate what's called each partial product. We have two products, a 30 times 10 and a 30 times 2. Aiden, what's 30 times 10? Yes, good job, 300. And you can use the 0 trick too. What you do is if you take your 3 and your 1 and you multiply that together, you get 3, and then you have 2 zeros and you tack them on at the end. What about 30 times 2? Morning. Yes. We're almost home free. Now I bet you can add 300 plus 60 in your head. Luke, 360 is our answer. Now, when you're going through this, you say, oh, that seems like an awful lot to write down when I could just naturally do it in your head. True. The idea is to try to do it in your head. You're just breaking down what those steps are in your head in written form so we can see what you're thinking. Let's try the next one together. It all follows the same pattern. Break one number apart, usually the number that doesn't end in a 0, and break it down into partial products. Order doesn't matter. 27 and 400, out of those two, which number gets broken up? Back. Right, we don't like numbers that end in anything other than a 0. We call them crooked numbers. We don't want crooked numbers. 0 is our friend. We're going to keep 400 intact. That goes outside. Break up 27. 20 and 7. Somebody had said in previous years, why not 10 and 17? You could, you still have one as a 0, but the next closest friend to our friends with 0 is single digits. We like single digits also. So 0 is our friend, and single digit numbers are our friends. Okay, so then show the multiplication of the number outside the parentheses with each number inside the parentheses. So we get 400 times 20 plus 400 times 7. And you can use the 0 trick for 400 times 20 because you don't want to leave any extra zeros off. What's 4 times 2? 8, right? How many zeros do you say altogether? How many zeros do you see altogether? Right, so 8, and add those 3 zeros. So 400 times 20 is 8,000. What about 400 times 7? Same thing, use a 0 trick. Panda. What do you get? 400 times 7. What's 4 times 7? How many zeros do you say? 2,800. Now squash it together for your final answer. 10,800. Okay? Ready for your first decimal? Here it comes. Now you got 200 times 10.6. Same procedure. Keep the numbers with zeros intact. Break up the other. What number gets broken up? Oh, right, 10.6. 200 goes outside. And now what do you break up to 10.6? What plus what? Sim. 10 plus 0.6. Works for me. Same thing. Multiply each number inside. We got 200 times 10 plus 200 times 0.6. Well, let's do the easy one first. 200 times 10. Beck, what do you got? Sounds good. Now here comes the tricky one. Before we do that, let me ask you a question. 0.6, is that less than 1 or greater than 1? 0.6. Less than 1, right? So our answer when we multiply 200 by a number that's less than 1, is our answer going to be greater than 200 or less than 200? Should be less than 200, right? We could kind of still use a zero trick because 6 times 2 is what? 12. Only thing is I can't tack on 2 zeros because 1200 is too big. But look, if this was 6, if it was 6, I'm bringing the decimal one place this way. I'm going to do the same thing here. 120. Is 120 less than 200? Add it together. What do you get? Sounds good. Okay, last one. We got to get one more in before the break, and then you'll be good. Before we leave. When you do your homework tonight, do it with a calculator. Let me get to the last one first, and I'll explain. All right, ready? Threesies.
What?
Threesies. First, let's do it. What number gets broken up? You'll see this is going to get broken up into 3 pieces. What number gets broken up? Yes. Yes. We don't like 25.4. It's a crooked number. Same thing. The number we like on the outside is 300. But you'll see now you got to take 25.4 and break it up into 3 pieces. What are those pieces?
25.
Right, 20 plus 5 plus 0.4. Good. Open up your agendas. I don't want to rush it. Your homework, rather than what it did say. It did?
Yeah.
Okay, well, I'll announce it now. I thought it said 6 through 10. What page are we on right now? Finish page 5. Doable? Do not check with a calculator. Just finish it up. Okay? We're a little bit behind, but not that bad. We'll make up time tomorrow.